Let's look at an example using direct variation. Suppose t varies directly as d cubed. Complete the table. The idea of direct variation is that as these d values increase, we expect the t values also to increase. So there were 4 steps we outlined. The first step is to write the general direct variation equation relating these 2 variables, and that is t equals sum k times d cubed. So the idea next, the next step is to find k using what you know. Well, we know d is 4 and a corresponding output of 5. So the idea is to input 5 there and 4 there to find our k. So here's what that looks like. We have that, and then solving for k, multiplying out the exponent and dividing. So we get k times 64 on the right side, dividing both sides by 64. We get k equaling that value, or as a decimal, approximately 0.078. So here the next step is to write the specific direct variation equation using our new k value. So that's 0.07 d squared equals t. So the idea now is to use this direct variation function that models this information to find those values. So the idea is to plug in 3 and for d, cube it, then multiply by that to get a t value. So let's do that on our home screen here. 0.07 times 3 raised to the 3rd power. 2.106 is what goes in there. So let's verify that we do get 5 when we plug in a 4 there. So I'm going to hit second enter so I can manipulate and input a 4. So we get close to 5 because this is a rounded number. So that's going to do. Let's input 9, 12, and 13. So I'm hitting second enter, and I'm going to put in a 9 there. So that's 56.862. So I put that in there, and then 12 and 23. So 134.784, running out of room there, and then 23. So 949.026.